Hello and thank you for subscribing to my channel Infowars Tech. This is module 3 of Enterprise Virtualization with VMware. Thank you for being with me through these modules, and I hope that by the end of this course you would have a very good idea of how VMware vSphere works, how the whole virtual infrastructure is set up, and allows us to then think about cloud computing, which is really the underlying basis formed by virtualization. So let's get started. In this module we will talk about vSphere architecture and configuration, vSphere interaction with CPU, memory, network and storage. So vSphere, we're looking at the whole ecosystem. When we say vSphere, it is comprised of a number of different components. As shown in this graphic here, it's a bit dated, but still most of the topics are still of use here. So we've categorized this in 6 different areas. We have availability, security, scalability, compute, storage, and network. When we talk about availability, the number one feature is VMware vSphere VMmotion. This feature allows us to migrate virtual machines from one host to the other without any downtime. So this is an extremely important capability from an enterprise point of view, as there is no downtime and we're able to migrate a virtual machine from one ESXi host to the other. We also talk about vSphere Storage VMmotion, which is based on VMmotion, but in this feature it allows us to actually move the virtual machine disk files, the storage for a virtual machine, from one data store to another. A use case is typically we might want to decommission a data store and we want to empty it, so we move out all the VMDKs, all the disk files to another data store, and then decommission the previous one. We talk about vSphere HA, high availability. This feature allows us to recover from losses, loss of a ESXi host, and any workload that's running on that ESXi host will be distributed on the other hosts in the cluster. We'll talk a little more in detail about this feature. Again, one of the very key features of the VMware stack. We talk about data recovery, data protection, fault tolerance. All of these features allow us to have very high uptimes and minimum downtimes. Even scheduled maintenance windows are minimized. The window is minimized by virtue of employing one or more of these features. We talk about security. Just a quick note here that the VMware vShield component is no longer supported from 6.5 onwards. It's now being replaced by NSX, which is the VMware Network Security Virtualization. In terms of scalability, we have DRS, which is Distributed Resource Scheduler, and HotAdd. DRS allows us to balance the virtual environment. So as an example, if we start off with a host with 40 VMs, the other host with 20 VMs, evidently assuming both the hosts are of the same configuration, this is an unbalanced configuration. So over time, DRS will look at key metrics like CPU, memory, the temperature, and then balance those workloads across both ESXi hosts. So after a few minutes or maybe a couple of hours, we might notice that both the hosts are now equally balanced. This allows us to have a very balanced workloads in the data center. When we talk about compute, the number one compute is ESXi itself. ESXi is the one that's providing the hardware resources for the VMs to run. So the storage, the underlying CPUs, memory, all of that is provided by ESXi. So the more powerful an ESXi host is. It allows us to run more powerful VMs or a larger number of VMs. Now, in terms of compute, we also have 64-way virtual symmetrical multiprocessing. What this means is that we can support 64 or even higher virtual CPUs on a single VM and 1 terabyte of RAM for the virtual machine. Now, do note that these are very high numbers, and an organization would require very specific use case to be able to run such a large configuration on a VM. And understandably, this would require a very, very large underlying host as well. In terms of storage, we have VMFS, which is a virtual machine file system. It's a clustered file system allowing very high performance and ability to share between multiple ESXi hosts. In the following pages, I have a few slides to go in a little more detail on VMFS. Thin provisioning is another very important concept, where it allows us to over provision our available storage, and in return we're able to run more VMs than it would have been possible with the other option, which is the default option, which is thick provisioning. We have additional features like storage DRS, profile driven storage reclamation. In terms of network, we have the standard switch, enhanced distributed switch, network IO controls, and other features providing high performance and availability, or even on the network side. Moving on, if you take a quick look at this table, the one of the clear patterns that we see is that as we move from a previous version to a newer version of ESXi, we see that there is a huge enhancement in terms of capability and performance. So if you're looking at VMware vSphere 5, which came around maybe 10 years ago, we could support 32 virtual CPUs for a VM and a terabyte of memory. We could support 3000 VMs per cluster. As we move to VMware vSphere 5.5, that came after maybe a couple of years, we see that there's an enhancement in terms of capability. We can support 64 virtual CPUs, which is double what was supported in 5.0. The number of VMs per cluster has gone up to 4000, and so on. We can also see the virtual center is also getting more and more powerful. As we move to VMware 6.0 and later versions, this trend continues. So with newer versions, we're able to support more VMs, more clusters, and very high performance. Let's look at some of the vSphere components. I'll go through these at a high level and just touch on some of the more useful ones. So when you talk about VMware ESXi, it's a virtualization layer that's installed on a physical server. It's also called a bare bone installation. It abstracts the processor, memory, storage, and resources, and allows multiple VMs to coexist. VMware vCenter server, it's a centralized one window management for configuring and provisioning and managing our virtual environment. It also provides data center services such as access control, performance monitoring, alarm configuration and management. VMware vSphere client and web client are ways to communicate with the virtual infrastructure. When we talk about VMFS, it's a high performance clustered file system for virtual machines, and the virtual machine disk files reside on these data stores. vSphere Virtual SMP, this enables a single virtual machine to use multiple physical processors simultaneously. As you saw in the previous slide, we can support up to 64, 128 virtual CPUs per VM. Again, a very powerful configuration for a VM. vSphere VMmotion allows us to migrate powered on virtual machines for one physical host to another with zero downtime. Very key requirement for any enterprise. Storage vMotion, again it's built on vMotion, and allows us to move virtual disks of a virtual machine to a new data store while the virtual machine is running. Again, great capability, allowing minimum downtime and as much uptime as possible. High availability, it's a feature that provides high availability for virtual machines. If one of the hosts fails for some reason, the virtual machines that are running on that are restarted on other available servers in that cluster, provided they have spare capacity. So the VM admin has to do some design work here to ensure that in the event of a failure, we should still be able to run our workloads, our production workloads. Now, a key thing to note here is that there is some downtime in the event when the operating system is powered down and then restarted, so that time is incurred. That's why this is high availability, and it does incur some downtime. This can also be called reactive technology, so it only kicks into action when we lose a host. When compared with the vSphere Distributed Resource Scheduler, or DRS, it is a preemptive technology. So it's running in the background, it's making sure that everything's balanced in the data center. And by balanced means that there's less load on the ESXi hosts, so they heat less, and the MTBF, the mean time between failure, increases. So DRS is important as it keeps running in the background preemptively as opposed to reactively for HA, and make sure that everything's balanced and running well. Distributed switch, it's an enhancement to the standard switch, and allows us to really be able to manage very large environments. So once the distributed switch is installed, it increases efficiency in the event that virtual machines, as they move from one host to the other, they are able to maintain consistent network configuration. Host profiles and auto deploy are related with how you would deploy a large number of ESXi hosts based on some common configuration. vSphere Storage DRS allocates and balances storage capacity and I/O dynamically across data stores. It includes management capabilities that minimize the risk of running out of space and I/O bottlenecks, slowing down the performance of virtual machines. So very similar to DRS, however, it's dedicated to ensuring that the I/O and data stores and the storage subsystem is working to best capacity. Fault tolerance, this is one notch above high availability that we looked at earlier. As I mentioned, in high availability there is a few minutes of downtime incurred, and that's just to the nature of how operating systems take some time to power down and then be restarted. If there is such a workload that an organization cannot tolerate any kind of downtime, then an option that is provided by vSphere, VMware vSphere, is fault tolerance. When fault tolerance is enabled, it allows us to immediately bring another workload, and there's no downtime at all. Resource sharing. This is a very important concept when we talk about virtual infrastructures, as all of this is being shared. As we can see in this graphic, we have multiple VMs and all of them are sharing. They're running in a ESXi cluster. They're sharing the CPU, memory, storage, and interconnect or network pools of the underlying hardware. So in terms of design and making sure that all the VMs are sharing the resources properly, there are some design rules to be kept in mind, which we will look at in later modules. But right now we need to ensure that all of the VMs play nice and they do not cannibalize resources that could have been used for other VMs. So resource sharing, Very important concept. We've looked at this perhaps in module 1, where we talked about the ESXi host. In that gray box, it has the actual physical hardware, which includes CPU, memory, storage, and network. And then we have the virtual machines running on that host, and each of them has a virtual NIC or a virtual memory, virtual CPU, and virtual disk, and all of them map to the actual underlying hardware. And ESXi virtualization layer is the one that is enabling this mapping and abstraction to happen. When we talk about VMFS storage, in the picture on the right hand side, we see a storage called VMFS. So a raw LUN is presented to ESXi cluster or ESXi host standalone. That LUN could be 500 gig in size, 5 terabytes in size. It all depends on our requirement. We take that raw LUN and we present it to an ESXi host. The ESXi host formats it with VMFS, which is virtual machine file system. Once it's formatted as with VMFS, it becomes a data store. Data store means that we are able to deploy our virtual disks on that data store. So as shown in this graphic, we have two ESXi hosts. Both of them have access to that single VMFS data store, and each ESXi host has 2 VMs each. Each VM has a disk, so in total we have 4 virtual disks residing on that data store. All of them are sharing the data store, and there is no issue in and VMFS is handling all the interconnection between the ESXi host, the VMs, and the data store. All of this is transparent to the application or the administrator. A closer look at the VMFS storage. In this picture we see a data store called VMFS1. It came from LUN 1. Perhaps it's 500 gig in size, 1 terabyte in size, not specified here. We have 3 ESXi hosts. All of them are sharing the data store. Each ESXi has 2 VMs each. Each VM has a single VMDK or a disk file. And as we can see, we now have 6 virtual disks residing on that data store. This data store is shared among 3 ESXi hosts, and 6 VMs are running on these ESXi hosts. So VMFS allows all of this interaction to happen transparently. It manages access and finds where the data is located. All of this is done transparently to the application or anyone managing that infrastructure. So talking about the data center topology, you have compute servers and storage networks and arrays. In terms of compute servers, we have x64 servers or hardware that runs ESXi. The installation is bare metal. That means there's nothing installed on that host earlier, and ESXi is the only virtualization layer that goes on top. It's the operating system actually. So each computing server is referred to as a standalone host in the virtual environment. Once they are grouped together in a cluster, they are then able to provide or aggregate those resources, and it's called a cluster. In terms of storage networks and arrays, we have capability to support fiber channel, which requires its own dedicated storage network, and iSCSI, SAN arrays, NAS, and NFS, which require or can run over Ethernet. vCenter server is a single point of management for the virtual infrastructure, and as studied earlier, it provides essential services such as access control, performance monitoring, configuration. It also unifies resources from the individual computing servers and is sharing that among the virtual machines that are running on the entire data center. Virtual center has a key understanding or key knowledge of all that's happening in the virtual infrastructure. So network, storage, virtual machines, each and every component, each and every instant of that virtual environment, virtual infrastructure is managed by vCenter server. So very important role played by vCenter server. Management clients allow us to manage our or look into, connect and look into our virtual infrastructure and manage it. It can be GUI based, web based, or a CLI based access. When we talk about a data center topology, this gives a very high level view. We can see on the top left corner we have a vCenter server on that network. We have a vSphere client, a web client. We might have a terminal for CLI access. vCenter server earlier could be on a Windows machine or a Linux machine. Now predominantly it's the industry has shifted towards a Linux based virtual center. Below we see ESXi servers running multiple VMs depending on their configuration, and in the bottom part of the picture we see each of the ESXi hosts has access to either fiber channel or iSCSI, NFS or NAS storage arrays. Another look, but from a point of view of resource pools. So once we're able to put these ESXi hosts in or aggregate the resources, then computing and memory resources called hosts, clusters and resource pools, storage resources called data stores, networking resources called networks, and virtual machines which are running the actual production workloads. Looking at another picture of a virtual infrastructure, we see on the top we have ESXi hosts with multiple VMs, and all of them are connected to the enterprise network, and by virtue of that they have access to network based storage, which could be iSCSI, NFS or NAS storage. Virtual infrastructure consists of the following components: bare metal hypervisors, which is ESXi, virtual infrastructure services such as resource management, automation solutions that provide special capabilities to optimize a particular ID process such as provisioning or disaster recovery. So all of these components allow us to manage a large virtual infrastructure, monitor it, and be able to support it in the event of a disaster or any other issue that could happen to that data center. When you talk about virtualization, the thing that we really get away from this is server consolidation. So in this picture we see we have physical servers, 6 of them. We virtualize them into VMs and move them into or deploy them on a single ESXi host. Now we can look at the savings in terms of cost and administration and management. So instead of 6 physical boxes taking space, requiring administration, requiring people to work and to replace any components, as well as taking up data center space, heating, cooling costs, we have managed to reduce those 6 standalone hosts into virtual machines and deploying them on one large ESXi host. So the cost savings can be substantial. In addition, the manageability really goes up, and also we benefit from some of the features that we looked at earlier, which is VMmotion, storage VMmotion, fault tolerance and so on, which were not previously available when the servers were physical. So thank you for watching and subscribing to my channel. Do stay tuned for module 4, in which we will cover additional features of VMware virtualization with ESXi. Thank you very much for watching.